Hello there and welcome to a brand new lesson. This is Hub Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at functional notation. By the end of this lesson, you should be able to read and write functions correctly using f of x notation. You should be able to evaluate a function for any given numerical input value. You should be able to evaluate a function for algebraic inputs such as f of a, f of x plus 1, and even f of 2x. You should also be able to solve equations in the form of f of x equals k to find the input that gives a specific output. And finally, you should be able to interpret and use multiple function names such as f, g, and h in the same problem. Here are some key vocabularies you can pause and then look at, because we'll be looking or we'll be working with them in the course of this lesson. Without much ado, let's look into it. So let's start by looking at reading the notation. If you see the notation f of x, it might look like f times x, but then this is not multiplication at all. So it actually means the value of the function f at the input x. You see, so the value of the function f at this input x. If we have f of x being equal to, let's say, 2x squared, then minus 3x plus 1. F we have here is the name of the function. The name of the function. Also, the x is the input variable. X is the input variable. And then we have our equal to sign, which is the rule applied to x. With that said, let's look at how we can evaluate for different input. So if you want to evaluate f of x for different input, all we do is we replace every x in the formula with a given input. You see, now this works for even numbers, letters, or even expressions as well. So for instance, if you have to say f of x is equal to 2x squared, then a minus x plus 3, and we are given an input such as 4. So that is to say f of 4. Then we just would replace any x we see over here with the value what 4, because it replaces our x we see in our function. So this then gives us a 2. Then instead of x, we're going to write into bracket a 4 squared. That is x being replaced by 4, as what's done over here. Then minus x. So the same x, which is what 4 over here, then plus 3. And then you do your evaluation. Evaluating this gives us a 31. I just want to demonstrate the substitution. In our subsequent lessons, we will go through how to actually evaluate. If we had f of negative 2 as well, then it is going to be the same thing. So we have 2, then instead of x, we are saying x is now a negative 2. So we are going to write 2 into bracket a negative 2 all squared, then minus your x value. X value is negative 2, so we have negative 2, then plus our 3. One mistake students make is when it comes to negative numbers, they ignore the bracket and it affects them. So you always need to show your bracket. Evaluating this gives us what? The 13. What if you actually have a letter and not a number? So if we had a letter and not a number, such as f of, let's say, a, then it is still the same substitution we do. This is 2x squared. This time around, our x has become a. So then it becomes 2a squared, then minus, instead of x, we are putting what? An a, and then plus the 3. And that is all. Now, there are special cases where we actually have algebraic inputs. For algebraic input, what we actually mean is it is not just one letter nor a number, but rather we have an algebraic expression in place of our function. It is very simple. You still have to replace every occurrence of x by the input you have over here. So as an example, let's take f of x, a function f of x, which is defined by 3x minus 2. So our first example here, let's say if we are to evaluate f of x plus 1, what is it going to become? It simply means that anywhere we see x in our original function, let's put x plus 1 all together in place of x. That is to say, we have our 3, then instead of the x has been substituted by x plus 1. So into bracket, we have what? An x plus 1. Then we move on. So minus 2, after which you do your necessary simplification. 3 times x gives us a 3x. 3 times a 1 gives us a positive 3. Then we have our minus 2. Simplified further, we have a 3x plus 1. As simple as that. What if we actually wanted f of 2x? So f of 2x is simply going to be 3 times x. Our x value is what? Now the whole of the 2x. So we have into bracket 2x, then minus 2. Simplifying, we have 3 times 2, which gives us a 6x, then minus 2. As simple as that. Finally, what if we actually wanted f of x squared? So it is the same principle. We substitute the value of x with what? X squared. That is going to be a 3 into bracket an x squared, then minus 2. Simplifying gives us a 3x squared minus 2. So that will be it for the tutorial section of this lesson. Now let's solve some questions to enhance our understanding. At this point, if there's any issue of concern, you can always let me know in the comment section. This is a very basic example which says given f of x equals 5x minus 3, you have to find f of 2, you have to find f of 0, and then also find f of negative 4. So our solution, first of all, we know our f of x is giving us what? 5x minus 3. So for the first one, which is f of 2, f of 2 is simply going to be 5. Then instead of the x, we substitute that with what? 2. So 5 into bracket 2 minus 3. Simplifying, we have 5 times 2, which gives us a 10. So we have 10 minus 3. And 10 minus 3 gives us 7. As simple as that. Our second one, that is b. It says f of 0. The same principle. So we have 5. Then x. This time around, instead of x, we are putting 0. So into bracket 0 minus 3. 5 times 0 gives us a 0. Then we have our minus 3. 0 minus 3 gives us a negative 3. As simple as that. Then for the last one, it says f of negative 4. Do take note of how you work with your integers, especially if they are negatives. So you have 5 into bracket. Instead of the x, we put a negative 4. Then we have minus 3. 5 times negative 4 gives us a negative 20. We have negative 20 minus 3, which then yields a negative 23. So we can conclude by saying, therefore, f of 2 gives us a 7, f of 0 gives us a negative 3, and then f of negative 4 gives us a negative 23. Let's look at our question number 2. Question number 2 actually takes a different form. It says f of x is fx minus 3. And we have to find the value of x when f of x equals what? 22. So this time around, the substitution has already been made, and we want the value of x that made f of x yield what? 22. We know our f of x is equal to 5x minus 3. And we also know that the f of x is equal to 22. So what we should do is we can equate 5x minus 3 to 22 because they are all what? F of x's. So it simply implies that 5x minus 3 gave us a 22. And it's now about making x the subject. If you want to make this x the subject, we have our 5x, which is equal to this 22 comes. Then for the negative 3, it moves to the other side to give us a positive 3. So we have 5x being equal to 22 plus 3 gives us a 25. Dividing both sides by 5, we are going to get our x, which is then equal to what? 5. So 5 cancels 5. We have x, which is equal to 5. As simple as that. So it simply means the pre-image of 22 is what? 5. And it was 5 that was put in there to give us the 22. As simple as that. Our third question says g of x is x squared plus 2x minus 1. We have to find g of 3, we have to find g of negative 1, and then g of x plus 2. So first of all, we know our function g of x being what? An x squared plus 2x minus 1. So for a, we have g of 3. And what is g of 3 going to be? We substitute x for what? 3. So that instead of x squared, we actually have a 3 squared. Then plus, instead of 2x, we actually have a 2 times what? 3. Then we have our minus 1. Simplifying, we have our 3 squared, which gives us a 9. Then plus 2 times 3, which gives us a 6. Then minus 1. 9 plus 6 minus 1 then gives us a 14. As simple as that. The second part says we want g of negative 1. So you do the same substitution. Instead of x squared, we have negative 1 squared. Then plus 2 into bracket x. X being negative 1. Then minus 1 at the end. Negative 1 squared gives us a 1. Then 2 times negative 1 gives us a negative 2. Then we have our minus 1. Simplifying, we have negative 2. Then for the c, that is g of x plus 2. So for g into bracket x plus 2, we know this time around that x is all of what? X plus 2. Since this is going to be a little bit longer, let me just do it on our next page. So we have the function says x squared. So all of this squared, that is x plus 2 all squared, then plus 2x. So all of this becomes our x. So 2 into bracket x plus 2, and then the minus 1. We'll now have to expand all of these. So for x plus 2 all squared, you can always use the identity. It is x squared plus 2x plus x squared plus 4x then plus 4. If you don't know this identity, then if you actually want to expand, you have x plus 2 squared, which gives us x plus 2 times x plus 2. That is to say, our x multiplies this whole bracket, and then the positive 2 also multiplies this whole bracket. Expanding gives us an x squared plus 2x plus 2x plus 4, which then gives us an x squared plus 4x plus 4, as you see over here. So let's evaluate that for this, and then we expand this as well. It simply implies that adjoint of x plus 2 now gives us x squared plus 2 all squared, which is all of this we have here. It becomes x squared plus 4x plus 4. Then we have 2 times x, which gives us 2x. Then 2 times 2, which gives us a 4. So plus 2x plus 4, then minus a 1. We can then group like terms. So you have our x squared plus, there is a 4x, and then there's also a 2x. Then for the numbers, we have a 4, then plus 4, and minus 1. Simplifying, we have our x squared, then 4x plus 2x gives us a 6x. 4 plus 4 gives us an 8, then minus 1, we have plus 7. And that becomes our g of x plus 2. Very, very simple. Our conclusion is going to be that our g of 3 gave us a 14. Our g of negative 1 gave us a negative 2. And then the last one gave us an x squared plus 6x plus 7. Question number 4. Our next question here clearly states that f of x equals 3x plus 1 and g of x equals x squared minus 4. We have to find the value or values of x for which these two functions are equal. So we know our f of x was given as 3x plus 1, and our g of x was also given as what? An x squared minus 4. Now if you are saying f of x should be equal to g of x, then it simply implies that this function, which is 3x plus 1, should be equal to this, which is x squared minus 4. So the main function we want to solve for, the main equation we want to solve for, is what we have over here. Now with this, we would have to what? Rewrite it so that it looks like a quadratic. So to solve this, our advice, let's move everything to the right hand side. Moving everything to the right hand side so that we have just 0 on the left hand side. We have 0 equals x squared minus 4. Then 3x moves to the right hand side to give us a negative 3x. Then 1 also moves to the other side to give us what? A negative 1. If you want to rearrange this, we have x squared minus 3x minus 4 minus 1, which when simplified gives us what? X squared minus 3x minus 5. This is our equation, and it is clearly a quadratic. So if you have a calculator, you can just punch and then solve. But then, since I would want to demonstrate without the calculator, let's take note. This is just as ax squared then plus bx plus c. So that is to say, our a is equal to 1, our b is equal to negative 3, And then our c is equal to negative what? 5. Now using the quadratic formula, we know the quadratic formula says that an x is equal to negative b, then plus or minus the square root of b squared minus 4ac, then all over r2a. So substituting our necessary values then simply means that x is equal to a negative, the b we said was what? Negative 3, plus or minus the square root of negative 3 all squared, then minus 4 into bracket 1 into bracket negative 5. And that is all over 2a. So 2 times a, which is 1. Simplifying further, we have negative 3 times negative 3 gives us a 3. So 3 plus or minus the square root of this gives us a 9. Then we have negative 4 times 1 giving us a negative 4, then times a negative 5, which gives us a 20, all over a 2. Still simplifying, we have our 3, which is plus or minus the square root of 29 all over 2 as our x. This is our final solution. Now we can take that of the positive and that of the negative all together. So our x has two values. The first one being positive, then the second one being what? Negative. So we have a plus and minus. Now, if you actually use a calculator, you realize that the square root of 29 is approximately 5.3. So for 5.3, if this is our x1 and then this is our x2, then our x1 is equal to a 4.19 and our x2 is also equal to what? A negative 1.19. So that we can conclude by saying that f of x is equal to g of x only if our x is approximately 4.19 or a negative 1.19. See, these are the conditions for these two functions to be equal. Now, to give you a picture of what has actually happened, you can see over here that I have plotted these two lines. The green one is the x squared minus 4, and this here is the 3x plus 1. It is a linear one, of course. Now you realize that the two functions meet at a particular place. You see, so let's trace out those points they meet. Tracing out this over here comes all the way to 4 point something. Now if we trace out this as well, you see that it also leads all the way up here to x being 1 point something. These are the values we have actually solved for. So this value here and then this value here. This is the 4.19 and this is the negative 1.19. So we are actually correct. You see, so this is how to solve it graphically. We'll look at that in other sessions, but then this was just to explain to you or visualize what we have done to you. We then solve our last question for this session. So our last question here is a very nice one, which says f of x is 2x plus k, where k is a constant. Now, given that f of 3 is 30, we have to find the value of k. Take note, we have f of 3 and then we are putting it into another function of f. before we get our 3. So first of all, we know that our f of x gives us a 2x plus what? K. We want our f of 3 first. So our f of 3 is going to be what? A 2 into bracket 3, then plus our k. That gives us a 6 plus k. After finding our f of 3, we are being told to input it into what? The function again. That is what f of 3 means. So let's put the whole of this in place of what? X. That is going to give us a 2x, where x is what? 6 plus k, then plus our k. Simplifying, we have 2 times 6, which gives us a 12, then 2 times k, which gives us a 2k, then plus the k we have here. This gives us a 12 plus 3k. But take note, from the question, we were told that f of 3, f of 3 is equal to what? 30. So if f of 3 is equal to 30, then it implies that this we have solved here is also equal to what? 30. So that is to say 12 plus 3k is also equal to 30. What we want to do now is to make our k the subject. Making k the subject, we have our 3k, which is equal to the 30 minus 12. You see? So simplifying, we have our 3k, which will then be equal to 30 minus 12, which gives us an 18. Hence, we need to solve for our k. And we do that by dividing both sides by 3. So that our k is equal to a 6. As simple as that. So that concludes everything. Now, we can verify and see. So, we first said f of 3 was equal to what? That is 6 plus k. So since we now have a value of k, it means it is 6 plus 6, which is equal to what? 12. So now let's look for f of 12. And that is 2 times 12 plus our k, which is 6. This gives us what? A 24 plus 6, which is also equal to 30, just as we were told. So therefore, k is really equal to 6, no doubt. So we'll end this lesson here. But as usual, I'll leave you with some exercises so you try on your own. So here are 5 exercises you can try on your own just to enhance your understanding. At this moment, you can pause and attempt before moving on. Let's have beyond numbers where we learn maths the easy way. If this was your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. If there's any issue of concern, you can always let me know in the comment section and I'll address that when notified. See you in our next lesson, and bye for now. Do stay safe.